Okay, here we go. Welcome to the notes for Math 53. You should know that these first couple of chapters are review of material that you did in Math 47, so we'll go through it fairly quickly. So we're going to start with section 1.2, and we're going to be talking about positive and negative numbers. So when we talk about positive and negative numbers or integers, we can look at a number line. And if we construct a number line here, you can see that as we go from 0 to the right, we are going in the positive direction. So this number I'm writing right now is a positive 5, positive 6, positive 7, and so on. And it goes on and on forever in the positive direction. As we go to the left of 0, we're going to be going in a negative direction. So we can make some tick marks and we can go, this is -1, -2, -3, -4, -5, -6, and so on. And it's again going on and on forever in a negative direction. So there are a few things that they're going to ask you to do. In 1.2, one of them would be to graph numbers on a number line. So that's example 1. So if we were to construct a number line, and as you construct a number line, as long as you make a pattern that continues, you don't have to mark every single one of the tick marks. For example, we could mark only the evens. We can do the same thing in the negative numbers. We'll go -2, -4, -6. So when they ask you to graph the numbers on a number line, they're literally just asking you to put a dot on where that value is. For example, -6, we would go to -6 on my number line and we'd put a dot. Then we put one on -2. There's the graph for -2. There's the graph for 0. The graph for 3 would be right there between the 2 and the 4. And the graph for 5 would be right there between the 4 and the 6. So now you see what I mean when I say that the first chapter is going to be fairly simple. How do we compare positive and negative numbers? Well, we compare them using these symbols, less than and greater than. So we're going to replace the blank here with one of those symbols. Well, -4, is that greater than 0 or less than 0? Well, if I look at my number line, there's 0 and here's -4. Since -4 is to the left, that means that -4 is less than 0. -8 and -9. Now my number line doesn't go quite that far, but I could always go out further if I wanted a visual. So for example, I could put -7, -8, and -9. So -8 compared with -9, well, you can see here are the two numbers on the number line, and since -8 is actually to the right of -9, -8 is greater than -9. Compare 0 and -6. Well, since 0 is to the right of -6, 0 is greater. And then if we want to compare -30 and +7, well, -30 is way to the left of +7. In fact, we could even extend that and say that any negative number is going to be less than any positive number. So there we have comparisons. Let's go ahead and let's look at what we mean by opposites when we're talking about positive and negative numbers. So by definition, opposites means that there are numbers that are the same distance from 0 on the number line, but on opposite sides. So if we look at our number line, 2 is opposite of -2. They're both 2 units away from 0 on the number line, but 2 is to the right and -2 is on the left. So that's what we mean by opposites. So 8 and -8 are opposites. -5 and +5 are opposites. So going to example 3, what's the opposite of +10? Well, that would be negative 10. What's the opposite of negative 12? Well, that would be positive 12. What's the opposite of 0? Well, that would be 0. So when we look at other examples of opposites up here, this symbol right here could be read many different ways. Most of us would just say negative. But for our purposes for example 4, we're going to say that this can be read the opposite of. So for 4a, we could read this problem as, what is the opposite of positive 6? Well, what is the opposite of 6? It's negative 6. This can be read, what's the opposite of negative 2? Well, that would be positive 2. Now look at C. This could be read the opposite of the opposite of the opposite of the opposite of negative 7. So if we kind of do it in stages, maybe do these two first, that would say what's the opposite of negative 7? That would be positive 7. Then we would say, okay, what's the opposite of that 7? That would be negative 7. And then what's the opposite of negative 7? Finally, that is positive 7. Now here's a trick when you have all of these negatives in front. And you can see that this trick works for 4A, B, and C. If there's an odd number of negative signs, by odd number I mean 1, 3, 5, 7, 9, or so on. If there's an odd number of negative signs, then your answer is going to be negative. Like here, there's 1 negative sign, 1's an odd number, the answer is negative 6. If there's an even number of negative signs, then your answer is going to be positive. For example, here, there are 2 negative signs. 2 is an even number, it's positive 2. For C, there are 1, 2, 3, 4 negative signs. 4 is an even number, it's positive 7. So remember that, and that will help you. So when we do something called evaluate, basically it means find the answer. And what we're really doing is we're going to, what I call, do plug and chug. We're going to plug in the value that they give us, and we're going to chug out the answer. So if you look at number 5, it says we want to evaluate this expression when x is equal to negative 2. In other words, we're going to go here, wherever we see an x, we're going to replace it with negative 22. So we would have that negative. We would have this negative. That's this one right here. And then just the x is going to be replaced with negative 22. This negative right here is not this negative. Only the x is replaced with the negative 22. So how many negatives do I have? I have 3 negatives. Because 3 is an odd number, that means my answer is negative 22. When we talk about opposites, that kind of leads us into something called absolute value. So the definition of absolute value is that it is the distance that a number is away from 0 on the number line. And the notation we use for absolute value is these 2 vertical line segments. So if we think of a number line, and I'm just going to quick draw a number line here. I'm not going to make it crazy. You don't even have to draw it, but it's just a visual. So if I take this number 3, what's the absolute value of 3? Well, since 3 is 1, 2, 3 units away from 0 on the number line, the absolute value of 3 would be 3. If I go down right here to negative 2, how many units away from 0 is negative 2 on the number line? Well, it is 2 units away from 0. So the absolute value of negative 2 is 2. By definition, your absolute value is a distance, and distance is always positive. Therefore, your absolute value of a number will always be a positive number. So let's see that in action when we go to example 6. So for 6a, what is the absolute value of 13? It's 13. B, what is the absolute value of negative 8? That's positive 8. C, what's the absolute value of 0? It's 0. Now, look at D. Let's read what this really says. This says, what is the opposite of the absolute value of 6? Well, that means what is the opposite of, and what is the absolute value of 6? It is 6. So your answer here is negative 6. Now, we have to be careful. That little rule that I told you up for example 4 doesn't apply when there are absolute values, so be aware of that. Let's see what this says. This says, what is the opposite of the absolute value of negative 32? In other words, what is the opposite and what is the absolute value of negative 32? It is 32. So the answer to that one is negative 32. So if you have absolute values and you have a negative on the outside, your answer is going to end up to be negative because you're finding the opposite of always a positive number, because your absolute value always gives you a positive number. Let's use absolute value and let's again look at some comparisons. So we're going to fill in the blanks with either an equal sign, a greater than sign, or a less than sign. So if we look at this first one, let's simplify both the left-hand side and the right-hand side first. So the absolute value of 0 is 0, and the absolute value of negative 12 is positive 12. Therefore, we know that 0 is less than 12. How about B? Now remember, what does this say? This says, what is the opposite of the absolute value of negative 2? Since the absolute value of negative 2 is 2, the left-hand side turns into a negative 2. And using the same logic, the right-hand side is a negative 3. So if you think of your number line, if this is my 0, here's negative 2, here's negative 3. Since negative 2 is to the right of negative 3, negative 2 is actually greater than negative 3. All right, look at this huge graph. So this is all the different sets of numbers. This whole box represents the real numbers. That's what this means. So everything that you know of right now is a real number. And in fact, everything that you're going to know of for this course is going to be a real number. So the real numbers have many sets involved in them, and you can see the list of the sets down here. You have the natural numbers, the whole numbers, the integers, rationals, irrationals, and then the real numbers. And each one of these sets is represented in this graph. So when you look at the natural numbers, that is the set of numbers that includes 1, 2, 3, 4, and so on. So that is a look at the natural numbers. No 0, no fractions, no decimals, none of that junk. It's just the set of natural numbers. They're also called the counting numbers because when you're, 2 years old and you start learning how to count, this is what you do. So that natural numbers, that is the smallest set of numbers that we have. So that is going to be this set right here. And notice each set is going to get larger and larger, and each of our next sets will encompass or include the previous set. So if we look at W, the whole numbers, to get the whole numbers, we simply add one element to the natural numbers, and that element is 0. But this set of whole numbers is larger than this set of natural numbers by one element. So this set right here is the whole numbers. Notice these are the whole numbers, and it includes all of the natural numbers. Now, how do we get to the integers? Well, the integers are the set of numbers that include all of the whole numbers in addition to their opposites. So when we list the set of numbers, you're going to have 3 dots there because it goes on into negative infinity. And 3 dots at the end because it goes on into positive infinity. So those are your integers. Notice still, there's no fractions, no decimals, none of that stuff. So our integers, by the way, and look, we use Z for integers, would be that set right there. Notice the integers encompass the whole numbers and the natural numbers because everything in these sets is also included in here. Now, rational numbers is where we start getting a little dicey. So first of all, rational numbers, we can't make a list like this because rational numbers are simply all numbers that can be written as a fraction. So all numbers x such that, so this is a little math speak here, so all numbers x such that you have a fraction a over b where a and b are integers and, by the way, b cannot equal 0. b cannot equal 0 because, of course, you can't have a 0 in the denominator of the fraction. So Q, which is what we use for rational numbers, are all numbers that can be written as a fraction. Everything we have talked about here are rational because we can take any one of these numbers, let's say 3, and we can write it as a fraction a over b by making it 3 over 1. Negative 1 over 1, 0 over 1. So all of these are rational numbers, but this also now will include numbers like 2/3 or 1.5. So it includes all of your fractions as well. So your rational numbers, your Q's, would be the next circle out or oval. Now, let's take another second and let's talk about rational numbers. So notice the definition. It's all numbers that can be written as a over b. So we just talked about the fact that it includes all the fractions, but it also includes some decimals. Decimals like 0.25, because 0.25 can be written as a fraction. 0.25 is 1/4. Okay? And in fact, it includes numbers like 2.36. That can be written as a fraction. We call those terminating decimals, decimals that end. Any terminating decimal can be written as a fraction, therefore it is rational. But wait, that's not all decimal-wise. Any repeating decimal can also be written as a fraction. If you took Math 45, you'll remember that 0.3 repeating is actually 1/3. Any repeating decimal, so even something like 0.267, where only the 7 repeats, as long as that is a repeating decimal, it can be written as a fraction, therefore it is rational. So rational numbers are a huge set of numbers. Now, where we have rational numbers, we have irrational numbers. And really, basically, irrational numbers are all x such that x is not rational. I know that seems a little weird, but that's really what we're looking at. The irrational numbers are weird numbers, just numbers that don't fit into a pattern. Probably the most famous irrational number is pi. Because remember, pi is actually 3.1416. It keeps going on and on forever with no repeating pattern. And that's really what irrational numbers are. If you see something like the square root of 10, that's going to be irrational. The square root of 9 is not, because the square root of 9 is actually 3. But the square root of 10 would be irrational because it's not a perfect square. You can plug it into your calculator, but your calculator will round it. If you see something like 3.2615 ... that's irrational. It has no repeat bar, and the ... just means it keeps going with no pattern. So Irrational numbers are this circle out here. Notice how they don't intertwine, because everything that's rational is not irrational and vice versa. But if you put all of the irrationals together with all the rationals, you get the real numbers. So the real numbers are all numbers that are both irrational, that are either irrational or rational. All numbers so that x is a rational number or an irrational number. And for our purposes, that's going to be all the numbers that you know. All right, so let's go down to number 8. I know this video is getting kind of long. So here's a set of numbers. And we're just going to go ahead and we're going to list each one of these sets. So natural numbers. So which numbers of these are natural numbers? Well, natural numbers don't include any negatives. Doesn't include 0 or pi. The only natural numbers in that list are 6 and 926. How about the whole numbers? Well, the whole numbers are everything from 0 on into positive infinity. So the whole numbers would be 0, 6, and 926. How about the integers? Now remember, the integers still do not contain fractions, but it does contain negative numbers. So it'd be negative 100, still 0, still 6, and still 926. Rational, Q, that's any number that can be written as a fraction. Well, negative 100 fits into that category because we can put it over 1. Finally, we can put in negative 2/5. 0 can be written as a fraction, 0 over 1. Pi cannot. 6 can, and so can 926. So notice each one of these first sets builds. But then irrational numbers are the weird ones. There's only one irrational number in that set, and it is pi. It is a number that can't be written as a fraction. And then, of course, real numbers is all of them. And there's your first set of notes, speaking of sets.